Today we're going to do a quick review of factoring and learn 2 more ways to factor. So first, we already know 4 ways of factoring: greatest common factor, dots, product sum, and grouping. Let's do an example of each. If we have 3x squared minus 6x, we can take out a common 3x and we're left with x minus 2. For dots, when we have a binomial, each of which is a perfect square, and it's separated by subtraction, we square root each piece and use different signs in each factor. So for 4x squared minus 81y squared, my factors are 2x minus 9y and 2x plus 9y. Product sum is when we have a trinomial. So if we have y squared minus 3y minus 28, we need to find 2 numbers whose product is a times c, here negative 28, and whose sum is b, negative 3. We find the 2 numbers that work, here negative 7 and 4y, split that middle, and rewrite it by taking a GCF out of each side. And we're left with y minus 7 and y plus 4 as factors. In factoring by grouping, we already have 4 terms. For example, we could have x cubed plus 5x squared minus 40x plus minus 20. So we automatically split the middle and take out a GCF on each side. On the left, that's x squared, and I'm left with x plus 5. So on the right, it would be negative 4, and I'm left with x plus 5. So my factors are x plus 5 and x squared minus 4. However, x squared minus 4 will factor more. It's difference of 2 squares. So my final factors are x plus 5, x plus 2, and x minus 2. So that's review of our old factoring. There are 2 new ways we can factor. We can also factor the sum or difference of cubes. We can only factor difference of squares, but with cubes we have a formula for sum and difference factoring. So, start with sum of cubes. If I have 2 perfect cubes, a cubed plus b cubed, I can factor them as a plus b times a squared minus ab plus b squared. Make sure you pause the video and get that written down. We'll do a couple of examples. We'll start with a cubed plus 27. Well, a cubed I'm going to rewrite as a all cubed, and 27 is 3 all cubed. So I can see what my a value and my b value are for the substitution into the formula. So a cubed plus 27 factors as a plus 3 times a squared minus 3b plus 9. 3 squared is 9. Let's do one more. Let's factor 64x cubed plus 1. Well, 64x cubed is 4x all cubed, and 1 is 1 all cubed. So here my a is 4x and my b is 1. I plug those into the formula, and I get 4x plus 1 times 4x squared, which is 16x squared, minus 4x plus 1. So to factor sum and difference of cubes, you need to just memorize the formulas and be able to substitute back in. So that was sum of cubes. Here's difference of cubes. If I have a cubed minus b cubed, that factors to a minus b times a squared plus ab plus b squared. Again, stop the video and write that down. Let's do a couple of examples. We'll start with 27x cubed minus 8. Well, 27x cubed is 3x all cubed, and 8 is 2 all cubed. So a is 3x, and b is 2. Substitute into the formula, and we get 3x minus 2 times 3x all squared is 9x squared, plus 3x times 2 is 6x, plus b squared, 2 squared is 4. And now I've factored the difference of cubes. 87x cubed minus 8. For our last example, we'll factor n cubed minus 64. I'll rewrite n cubed as n all cubed, and 64 is 4 all cubed. So a is n, and b is 4. Substituting back in, we get n minus 4 times n squared plus 4n plus 16. So again, we have two new formulas for factoring, sum and difference of cubes, and our old factoring. Have a good night.